or at least starting on building some static analysis algorithms using Haskell and Datalog. And I had some ideas on combining multiple analysis passes. So yeah, I will be experimenting with that today. So let's see. Let's first remove all kinds of things, and let's also start the terminal. Wait. I need GHC ID, but not this one. Should be this one. Okay. Okay, it's compiling now, but I needed to run my command. And I always forget how to do this. main like this. Yes, this is what I need. Okay, so let's build two kinds of algorithms. So first, well, one of them is name shadowing. So let me make a block comment. So we will be making a language in a few minutes, and yeah, it will be a really simple one, but it will be possible to have name shadowing, just so we can test that this works. So if we have something like, yeah, let me use like a Python-like syntax. So we have a function taking a variable x, and then you say y is 42, then you create maybe another function like function 2 that takes a z, and then here you can also say y equals 1000. That's one option, but maybe we can make it even simpler, so that because yeah, here we have an x, and if we say here that x is 42, or this is not really Python syntax anymore, but if we say x is 1000, then this should give a warning, and yeah, and this also. I have no idea how to build this yet, but that's a problem for later. That's one pass I want to build, and the other one is what's it called? Oh, first I also need to check the stream before I forget. Let me see. Looks to be working. What was the second pass? Well, what we can do is we can start with name shadowing and then go from there. Yeah, let's do that. So first we need a language. Also, why is it complaining? Oh, silly me. Yeah, that's because it's gray on black. Anyway, we need like a statement-based language, I guess, with well, we need like a block with more statements inside. Then we can do this part, and we need an assignment of a variable to a value. Let's just do integers for now, keep it simple. So we have that, because you, oh well, actually that is already enough, I think. Then we don't have this, but implicitly you have a block at the top level. Yeah, that works. Okay, And what I usually also do is I built like a list of scenarios, but yeah, what is a scenario right now? I guess it's a statement. A statement is actually also a kind of program. And then here we can say for scenarios, first print it out. That should work. Oh, that's not known. It's the first time I'm using Haskell language server, by the way. So I'm testing out the code actions and I'm already dinging it. So be happy with that. Can I do a code action here as well? No. Nope. Still need to figure out what's possible and what isn't. But yeah. So let's make a block with more statements inside. So here we say that x equals to 42, like the example that's just visible at the top of the screen. And then let's add or create a new block where we say assign x equal to 1000, and let's also do another variable to 2000, and let's assign value z to 100. Completely random, but it will work. Okay, so that's an important step, and something else we will need is souffle Haskell. Oh, this is nice. Even code completion on the modules. Let's take this one. Wait, no. I need the experimental one. And let's see. We will be building an algorithm. Yeah, and now I don't know the the order of the type variables anymore. It's been a while since I used it. Nope. At least I tried using code completion. Let me see. So, package. Then, still half asleep, so bear with me. No. Okay, so it's a program, then definition, and then unit. So name shadowing, then definition, then unit, and then it will say, I don't know this type. Name shadowing. Okay. Yeah, this is like a handle kind of data type. So yeah, we need like a single constructor with no arguments. And now what we want is we want to run this code. So I think I do need, well, let's make a run function, and what goes inside a statement, and we will get back a list of shadowed names, and let's make a data type out of that. data shadowed is shadowed, and then string is fine for now, I guess. We will be printing that, so we need show. And now I need run souffle interpreted, and that takes, oh, the type definition in line is super nice as well. That takes the shadow, the name shadowing handle, I think. Oh no, my bad. Let's see. So it takes a program, then a DSL fragment, and then a function. So that's 3 arguments. Yeah. So name shadowing, and then, wait, there's something else. Yeah, trying to fix the errors here. So I need to put the fragment in here, so algorithm. And then here, so here we need IO, I guess, because if we run souffle, then it will be in the IO monad. Okay. I'm a bit rusty on the Haskell. Oh, this needs to be live.io, I guess. Whoa, that's a lot of 11. Yeah, we need to print, run. Oh no, we need to get the shadowed names. Let's just do it like this. Run scenario print names. And then it's still complaining. Oh yeah, we need to add all kinds of metadata. So instance program facts for name shadowing is shadowed for now. Oh. Oh, this is so nice. Where has this been all my life? Yeah, let's call it name shadowing on the Datalog side. Yeah, I need to go over the facts and extract them. So, and I need to write the actual algorithm. So let's do that maybe first. So when is something shadowed? We need like a predicate. Shadowed is predicate for. Just enabling the the extensions with the code action. That's so nice. what's going on here? Wow, that's a big error. Oh, that's probably because we need to add that shadowed is a fact. Fact name is const shadowed. Okay, then we also need Marshall. Could not deduce. That's an ugly type error. Oh, I need to derive generic. Oh wow, that's a. I need to fix that. Code actions all the way. Missing methods. What's missing? Don't know yet, but we need fact metadata here. Yes, that's right. So that's an output. So okay, the errors are finally starting to become normal again. Let's see. So I need to figure out when something is shadowed, and something that we will need is scope. So how do we do this? Let's take a look at the program. So this would be scope 0, and this would be scope 1, and if we go even deeper, that would be scope 2, and so on. Yeah, let's see. So and then what we first need to do is we need to add the concept of scoping. So we have a scope. It's going to be an int32. It doesn't know that yet, so let's do that. Oh, we need to add a fact for scope, or let's copy this. Scope is an input. It's called scope on Datalog side. And add. Okay. We need like a way to say that a variable is in a scope. So if we go back here, so we know that we have scopes now. Well, maybe a scope doesn't have to be a fact. Like, maybe we can have like a declare variable kind of fact, and then the scope goes in as an argument. Maybe that's better. Yeah, let's try that. That does mean that we have to refactor a little bit. So scope is just an int32. This is gone, something we will need is declare var, and that's or like a define kind of thing, and that define has a scope and a variable, and then here we put this, and then Okay, so here we also get a define for that. Oh, and now I need to add it to here. Why is it complaining here? Oh. Too bad it doesn't have a code action to add the primes before it. So what we can say now is, well, I think we need another kind of fact. So now we can say when we have a variable. So in this line and this line. But on this line we need to say that scope 1 is nested in scope 0. So how do we call that thing? Yeah, something like nested. That's not the name I like. So and also we have two scopes here. So maybe this is like top scope or parent. And then, yeah, it's not really a child, but something like this. I really can't type today. But I want better names for this, so maybe I should try renaming this first. Let me see. Child is nested in parent. That sounds wrong. Let's rename that. Sub scope, I guess. Like this? No. Maybe this is just, yeah. So the subscope is nested in scope, and then we do this dance again, and then we add a block of code like this, nested scope, nested scope, nested scope. That's also an input, that's right, and then okay, it's happy again. Now we can say okay. Oh, wrong direction. Let's see. Let's do the actual algorithm. So a variable, we need a variable first. So let's not call it that because that would give problems here. Do I even Haskell? Now we can say a variable is shadowed if you have, oh, and then we need, or like a scope, and then subscope, if you have a scope and a subscope, if you have a define on of a variable v in a certain scope, and if you have a define in a subscope. Nice. Why is it complaining here? Disable name shadowing. Oh my god, that's just ironic. Let's see. Here it is. It's not that pretty, but let's refactor it later. Okay, so here we need to put our actual code. We need to run, so to do get the facts, insert into souffle, and then here we need to do get facts out. Well, this one is easy, I think. Get facts of program. Oh, it's called S now. Okay, that part works, so that's done. It took me longer to write it to do than actually doing it. We need to get the facts. So how are we going to do that? Let's make a helper function. Extract facts of the, like this. Yep. Wait, did it define it? Oh, I'm completely blind. Wow. This is nice. And what's it saying now? Oh. Okay. So now here we get our statements. So we have either a block or an assignment. And then assign var value. So one thing we need is we need to have like some kind of state. Let run reader 0. Oh, run reader t, I guess. Why is it complaining? Not sure yet. But here we have to do local and then +1 and then the statements. So this 0 is like the starting scope. And then traverse extract facts. Wow, that's a big type error. Oh, my bad. But its type has none. Let's go a step back. Let's go another step back. So let's so what we want is I want to run reader t, and then something and something else. Here goes the 0. That's the top level scope, and then here the statement goes here. Okay, this is a little more readable. It had to do with the dollar, probably. Okay. So if you do this, okay, I think we're good again. Oh, yeah, that's annoying. So what we want is like a function f, which helps us, and f is defined as this. And then here, this is not this. Okay. Yeah, so extract facts uses a helper function now, and that helper function is in the reader monad, so that's why it works. And here something else we need to do here is we have to go inside those statements, but also when we need to ask the current scope, ask, I guess, when current scope then we need to say that we are nested scope of so let's previous scope is current scope -1. Did I not call it nested scope? Okay, that seems to work. So, yeah. Maybe let's do it like this. So we add that the nested scope fact, and this is kind of easy right now because we have such a simple language. But yeah, if it's a more complicated language, then you would have to keep track of the previous scope, which can also be done in the reader T with a list maybe. So let's see. What we want here is add a fact. Oh, we need to get the current scope here as well. We are not interested in the value. Oh. Okay. Wait, so I think it's already starting to work, but I made a mistake in the scenarios. So what I wanted was this. So you have a block with an assignment, then another block inside and an assignment. Oh, and let's make this first scenario. That's really easy. And let's Okay, so back to the scenarios. So for this one, nothing is shadowed. We need to add the line at where it is shadowed. And we can also add a line that causes it to shadow. But those are enhancements, so let me first check this. So if we have an assignment of 42, then it says, yeah, nothing special going on. If we have a block, if we have a block like this, this is also name shadowing, but in same scope then. That's maybe another case we have to tackle. Or we can say that it's not allowed. Yeah, let's. I wasn't. Wait. Because of mutable reassignments. Let's make that into a second pass that we will add later. So scenario 1, declaration in the nested scope, and then or just assignments. Then here, yeah, this is, yeah, we can keep it like that. Yeah, but let's tackle that in a second. So this one should give a warning, or at least it should say, oh, this variable is reassigned by that one. Yeah. Let's see. Oh, I was adding scenarios here. So if I save now, the first scenario finds nothing, the second one also finds nothing, but we need to fix that later. And the second one has an assignment here, and then a nested block there, then X is reassigned, so that has shadowing. Yeah, and then it has a final assignment to Z, but that's also never reassigned, so that's fine as well. Yeah, I can think of another scenario that we might want to tackle. And that's if you have Z here, and let's remove this to make it easier or more contained. Yeah, so I need to add the line numbers at some point, or like a node ID. Yeah, this one requires a control flow graph, I think, and then because then you can say that this statement is followed by this one. Yeah. We can, that's another enhancement we can add later. Are there more variations that I can think of? So we have x. So we assign here and then here. Yeah, I think this is fine for now. So what I want to do is I want to make a commit. So git status. Oh, git checkout -b. Where's the version of analysis. Okay, and then I want to go, what I want to do now is I want to play around with recursion schemes. So yeah, I think that would be mostly related to that function. But this will be, yeah, let me see if I can make a function like that. So prime okay. Whoa, can't type. No, okay, so program, yeah. And then what we have to do here now is we have to follow the README of recursion schemes. I haven't used this library too much yet, but I know we have to do some stuff with is it here in the template Haskell one? Yeah, here it is. Make base functor. So make base functor with 2 primes, okay? What? In place? No. Variable not in scope, okay. Need derive functor. So let's do that. Oh, nice. Just having the code actions is so nice. I will be saying that a lot during this video. So what is this? So we get a block f, I guess, and an assign f. Oh, 2 arguments. And here we already get the actions. So what we do is we get the current scope. This part is the same, but then this part. No instance for monad reader. Oh. So what I think we have to do is flip from reader t can type 0 of kata f. Oh yeah, algorithm I guess. Where algorithm is. Oh. Okay, like that. And then here local +1 traverse actions. No. Is that full M then? Let's go to Google. So, oh, probably overlooking something really stupid here. Fold map, is that not an option? No. Oh yeah, because it needs, So previously we would call the recursive function ourselves, and now we just have to run all those things one after the other. But that does sound like fold M, but nope. Well, what we can do is we can go here. It's like the opposite of replicate M. M sum. That's a good one. I haven't built Monad Plus yet for the Souffle Monad. Let me see, is IO Monad Plus? Because then I have to add that. Well, we can check it out. It is. Oh, but only recently. Wait, is that recent? No, that's recent. Okay. have to write that one down. Old school like that. Okay, yeah, I have to add that, but that means we can't use it right now. That's kind of silly. Is there another way? Because yeah, it's exactly what we need. Join. No, we can't use join because we have a list. I think the closest we are going to get is full them, and then we have to fill in a function here and a starting argument. Well, another thing we can do is this, right? What? So now it's saying list f. Okay. Yeah, let's call this one f then, I guess, and then f is case, and then nil f, pure, and then cons f. Oh, is that just nil? Okay, so action 1, action 2, and then a1, a2. Yeah. Feels a bit crappy, but let's go with it. And that's also the reason I use my own library now, so that I find stuff like this. Okay. So, if all is well, this should compile and give us the same, but it gives us nothing. Why? Let's keep the whole code right next to it. What is different? So here I first do the local of +1. So I have to do this. Yeah, it works again. Nice. Nice. Well, the code is maybe a little bit more complicated now because of recursion schemes, but if you add if you do this, this doesn't make sense right now, but if we add another case here, yeah, what could we add? I am really having a hard time today to find some examples, but yeah, let's just add a print of a variable. It still works. And that's the power of recursion schemes. With the previous approach, if we did this and we had like a nested kind of structure, then it would stop. And now it's automatically handled like that. That's cool. Yeah, this monad plus thing, maybe I will fix that on the stream as well. Still good on time. But first let's make a commit. Okay. So that's already quite a thing. But I wanted to combine multiple passes. So what we need now is we need to go back here and take a look at this example. So if we are in the same scope, but we have multiple defines with a different line number, well, I could add that to the current example. Let me think. Can I think of another analysis pass that's different enough? Because what I want to do is I want to combine multiple passes into one that are really different. Yeah, I can't think of anything straight away. Maybe what we can do is instead go to Soufflé Haskell and let's park this for a little bit and let's see how hard it is to add monad plus, and hopefully by the time I do that I figure out how I want to tackle this. Oh, that does mean that I lose my my code actions. Too bad. Yep, that one. What is this? Oh, it's regenerating the index. But on the left side we can go to interpreted. I think it's really easy. Can't add it here, but I can add it there. Alternative. Does that make sense? So then we can do some and many also. Oh wow. Okay, what is alternative for IO? It's fail IO. Not sure if you want that. So let's see. Let's play a little bit in the terminal. So empty is IO of unit. Oh, what module was it from again? Control.applicative. So that's an exception. Not sure if I want that in my library. Let's take a look at the types. Can I figure out yeah, no, I have to do the same thing for souffle because it builds on top of IO, and if you don't know the A ahead of time, then yeah, you can build an IO action, but if you don't know the type ahead of time, then you have to make an error there. Oh, is this maybe what we want? Just sequence. Then we don't have to do all this. Oh, perfect. Yeah, so in the past, I'm not going to do this step, but I came across the exception in the past, and that's why I didn't add it, because I always try to add as many instances as possible. Yeah, this is even easier. Just sequence, done. I like that. Okay, that's that thing wrapped up. Let me maybe commit that part. So what I can do is, what we can do is we can make an unbound variable kind of thing now, maybe. But that also requires a control flow graph. You need it in quite a lot of scenarios. And I'm trying to avoid that because that last time I did that, it was already quite difficult. Let's see. Let's just Google for some examples. Yeah, or we can recreate the example we had last time. Yeah, that does mean. Yeah, let's do the unbound variable one. Yeah, okay. So algorithm, where is that? So let's call that shadowing algorithm now, because we will have two algorithms. And now here we will be building use let's see where we end up with this algorithm. Ooh, that's a long name. DSL, unbounds variables, definition, okay, so unbound variable, that's our handle data type. Let's see. Yeah, I'm already trying to think ahead, and I shouldn't do that. So what we need is we need a define, and we have that, but we also need like a use fact saying that we are using a certain variable at a certain line. Well, yeah, and then type line is in 32. Oh, far, I guess. Yeah. Generic fact metadata. And you could do everything all in one algorithm, but that would get a little bit unwieldy after some time. So I'm trying to see how can we split it up into multiple parts. Use. Now we also need Marshall. Okay, it's happy again. Predicates. Yeah, we need another kind of fact. Unbound variable line. Let's repeat that. Let's add show. Well, or we can call it use before define, but yeah. This is an output. Oh, so unbound use define. of windy outside. When do we need to have variable for variable, and we need to have like a line of code, so for line. Then something is unbound on a certain line. If we have a define, yeah, this is going to give problems. So, and then a use, and then 2. Wait, no, this needs to be line 2. And line 2, so the use is before the define, so it has to be less than. So, and what we need here is line 1, line 2. Yeah, and now this is complaining, so how is define defined? With a scope. Yeah, but we want this to live in its separate thing. Because I want to refactor it later into 2 modules. So we need like a different kind of define. That's okay. Means a little bit more boilerplate, but so we define a variable at a certain line. That's good. Then okay. Yes. Okay, that's better. So we need to uncomment this. I was happy about that as well. And what we need now is, let's see, we need this kind of function. And we will be merging that with run later, but not yet. So here we put the unbound unbound variable. Okay. It's not happy about this. What is going on here? Oh yeah, this needs to become extract facts, and then here unbound has to be returned. Okay, and then here yes. And for this one, let's first delete everything. Well, let's do it differently. Let's put all this in comments. So yeah, let's pattern match on a block statements. Assign okay. Yeah, so let me think. We will need the line numbers somehow. So let's fill in the easy cases. So s.add facts program, then use, and then a variable, and then a line. This is almost the same. Don't care about the value. Oh, and also let's use this run. Okay, so we're using that now, but yeah, we need the line numbers still. So let's see. Yeah, the line numbers are annoying. How do we do that? Because I could use a state monad and then increment just for every statement, and that would work, but I want to have a reader here as well, otherwise I won't be able to combine them, I think. Let me see what the signature of okay, let me see. So what I want to do is I want to say at the end, extract facts with the program handle so that you only get this part, a statement to that. But the problem there is, well, what I want is that, yeah, I think that's possible with the way I'm going to do it right now. But I only want to run kata once. So what's the type of this? So this is statement F. Oh. Of reader T scope. Yeah, and this is, yeah, okay. So what I want to do in the end is I want to put this at the top level. Is reader a monoid? Otherwise that won't work anyway. Don't think it is. Oh, that would suck. This one. Don't think it's a monoid. So this is saying monad reader is no. This is about the writer T. And that requires the monoid. Oh yeah, I can also look here, but that's annoying. So the idea I had was to combine those functions together, and that would work because hang on a minute, where first monoid. Yeah, IO is a monoid, and souffle monad builds on top of that, so that's also a monoid. But if reader isn't a monoid, then you're stuck. That's exactly what I have right now, so I would have to get rid of the scope. Is that possible? Well, so I think it is possible if you, reader T, so you can probably transform this into this. Yeah, it's breaking in all kinds of ways now, but this is still a problem. I think. No, this is fine, but it only works if if the other algorithm also has scope. Because otherwise you can't compose algorithms together. Yeah, that's annoying. I have to think a little bit more about that. So let's see. Well, I think it might be possible if let me hello, by the way. What I'm working on is so I built a library that combines Haskell and Datalog. So I am using the Souffle Datalog. That's this one, and that's like a super fast Datalog variant. It's not the same as the one used in the Rust borrow checker, because that one also has a Datalog inside, but I think that's this one. I still have it in my history, and if you want to learn more about that, you can look it up there. But algorithms like the borrow checker and also the static analysis stuff I'm building now, that's super easy to build in like a Datalog, and you are talking about Polog, but that's also possible there. So I built my library called Souffle Haskell. Let's go back here. And this one makes it possible to communicate with Souffle from Haskell in a really easy way. Like, you can just define your facts as normal Haskell data types, and it will work like any other Haskell code, I guess. And what I've been doing is I've been streaming a lot with experiments. Yes. That's one of the the negative things about it, but for the rest, it's a really cool piece of technology. And yeah, I've been using it for a lot of experiments in all kinds of parts of the compiler. So chalk. Oh, so it's yet another data log. Okay, first chalk. Cool. Yeah, here, Prolog like logic solver. I need to look this one up. But it is a data log. That's the, or maybe even a Prolog. So that's the important part. Because what you have with static analysis is you define, well, if you take a look at your code, you try to figure out what's going on, and then you say, oh, I see this and I see that, and those are all kinds of facts, and that's what makes it really nice to program your static analysis and data log, because you can just create data types for the facts that you come across, and you push it over to the souffle side, and then you can compute relations on that, and you get facts back. It's a really easy way of thinking, and yeah, that's why I've been experimenting with it in all kinds of or in different parts of a compiler. But yeah, I can probably refactor this, but yeah, let's do that later. I don't think I can finish it today anyway. Oh no, yeah, I mean facts. Like I see this, so if I go back to no, it's more at the bottom. So here, if you come across an assignment, then I say yeah, I ask for the current scope, and then I just add a fact to souffle, saying that we have a define at this point, and then I have this algorithm here somewhere, not this one here. There's a little bit of magic going on here, because this Haskell code is translated to Datalog, and then I communicate with Haskell from that. And here you can say which facts you come across, and then you can, yeah, what this is saying is, if we have a nested scope, so we have a subscope that's nested inside scope, and if we also have a define of a variable in like the upper scope, and we have a define in the nested scope, then you have name shadowing, and then it will return, yeah, what this is saying is, if all these three are true, then it will yeah, kind of record a shadowed fact, and that's the fact that we extract at the end. Because here we are saying get facts, and then we return a list of all the results. And because these are also facts, you can keep on putting them back into souffle and computing more and more. So yeah, it's super powerful, and it's really fun to play around with, because this would probably be a lot complexer if you do it in just Haskell. Well, there is some boilerplate of having to send it back and forth, but yeah, the algorithm itself is easier. What do you mean by that? Stronger propositions subsuming weaker ones? How do I say this another way? So you have like input facts and output facts, and these are all inputs basically, or they can be defined somewhere else in the program, but let's keep it simple. Let's say these are all input facts. Well, you can combine them. Well, if you see that all these things are true, then you generate a new fact of type shadowed. And then further on you could do like dead code and then something something. If we have a shadowed variable, then it's dead code, something like that. So that's what I mean by you can use your facts in other facts or in other relations to create more facts. And we are just adding more and more facts to the system, and we get more and more knowledge back out. And that's all it is. Yeah, that's some syntactic sugar here. So normally you would put the colons here. But yeah, it's Haskell and it has to be valid Haskell code. So I made it so this monad here does the conjunction of all these things. It's also possible to do an OR, but I haven't needed that yet. And also if you can also do an OR in this way. You can just say a second block and then some more stuff. That's also an OR, because it will trigger if either all these things are true or if all these things are true. But this is more magic of my library that converts the do syntax to Datalog code. No, it's fine, it's fine. I like the interaction. I was kind of stuck anyway, so it's fine. I need to tackle this issue some other time, but let's see if we can figure this one out. So I think we will do a similar approach, but with the instead of reader we will have state, because I haven't figured it out yet how it should work. So yeah, I always get confused with state. Run state. So what I want is, I'm only interested in the result. I think that's this one. Yeah, eval state. I'm curious. Yeah. Like that. It gives me a type error. Oh, eval state t. Okay, that's better. Yeah. So this is now the line number, and this is really ugly, I know, but first you have to make it work and then have to make it beautiful. So I guess how do we do this? Like increment is modified +1. Get line. I hope that doesn't shadow. Then get. What's it saying here? Oh, I don't have a where. Huh. Oh no, this one has to go one back. Yeah, it is shadowing, so get the line number then. Or get position. Yeah, I think that's better. Why is it complaining here? Probably because it's not used yet. So what I want to do is I want to trigger. Now what I want to do is I want to trigger increment, and that's just to modify I want to do that before each of these actions. So how do I do that? I guess like this. No. Because the statement has to go inside here. Well, I can cheat a little bit. I can say that this takes an argument, and now I can compose these two. Does that work? No. Wait, let me first do the non-fancy version. So here we get a statement, and then here we say increment, and then we call the algorithm with the statement. Still not happy. Too few arguments. Oh, yeah, because we need to do this now. Okay, I think it's happy again. But increment is only called once at the beginning now, I think. That's not good. So let's call this algorithm prime, and then algorithm is, the statement goes in, you do increment, then you call the algorithm like that. Okay, it's still happy. Now it should increment each time we call algorithm. And yes, the functions have to be made better in the future, but not yet. So here we can now say, give me the current line, I guess. Get position. Now we can fill in the line. And it's not happy here. Why? Traverse algorithm statements. Oh, this is just get now. Okay, starting to get somewhere. Can copy this here, and then line. Okay. That's shadowed. Oh, that's the first mistake. Can we do this? Does that work? No, trying to be too fancy here. Let's just call this. There's probably some kind of magic incantation that I'm not figuring out. Yeah. Okay, so now what we are seeing on the right side is the results are always empty. Strange. Did we overlook something? Well, what we can do is trace use, and then here trace. Oh wait, that's also a use. That's not good. Here this is a use, this is a define. define. Still nothing. Oh, probably because we need a scenario for it. So let's add a scenario. So block, and then print x equals. Oh no, we just say print, and then assign 1. But there's even an easier case, just x. Okay, it's starting to work now, but this one it doesn't see it yet. So, well, use for 5. So I think we have to make it smarter. So something is also unbound if you have a use, but no define. Oh, it's not the exclamation mark. It's like this. Yeah. Okay. So let's make this by 1, I guess. Flipped around, reads a little bit easier. So yeah, in my DSL, the wildcard in Datalog is underscore, but in Haskell that's already taken, so I had a double underscore, or you can say this also, I guess. Yeah. But this one, yeah, it's an experiment anyway. So this is saying if we have a use but no define, then it's unbound. If we do have a use and we have a define, and line number 2 is less than, well, let's flip this stuff around as well, because that reads easier. Yeah, still works. So if you have a use and then a define, and the use is before the define, then you also have a problem. And now I also want a scenario that does both. So what's the easiest one there? Guess that. So we have that, and we can do this. What's going on there? Oh yeah, it doesn't understand that one yet. Well, it knows this one. Whoa, hang on. So, hang on. Yeah. So in the final example, you see that it returns that x is shadowed. Well, we didn't make it smart enough to say at which line, but we know it's shadowed somewhere. And we know that y is unbound at line 5. Well, 1, 2, 3, 4. Oh, and this is also 1. So 1, 2, 3, 4, 5. Yeah. So the algorithm works, but yeah, it's messy and it has to be refactored, but that's maybe something for another time. So let me clean this up a little bit and commit it. And yeah, we got quite far already, but what I want to do is I want to do one catamorphism, so one fold basically, Where is the code? Here it is. Because if you just give extract facts this program argument, then you get a function, and a function can be combined with another function if the last argument is a monoid, and that is the case because a function of statement to my souffle monad, that's a monoid, because the souffle monad is also a monoid. Yeah, it's intense, but yeah, this thing is a monoid. That's the most important part. And that's that will allow us to do stuff like this. Extract facts program. But the bad thing about this is if I rewrite my example at the bottom of the unbound variable algorithm, then it will do kata once in this function, and it will also have to do kata in the other function. And that's not what I want. I want to do one kata that goes over the data structure once and collects everything. That's the challenge, at least. On the library side, it's already fine, but here in the implementation, I have to refactor it a little bit. But I think that will be for another time. We already got quite far that we built 2 static analyses in like, what, less than 2 hours? Yeah. Let's see, can we refactor this a little bit? So what did we all write? We wrote this entire part. This is the description of our unbound variable algorithm. Then we have our run function. And then we have this part. So what I want to do, maybe I should already commit what I have now. Analysis. Oh well, it's only a playground repository. So what I want to do now is I want to combine the run functions. So let me grab this code and let's put it here. Let's put this code here. Okay, let's see. So what I want to do now is here I want to return the shadowed and the unbound stuff. So it will already complain. What's going on here? Somehow complaining about the types. Oh, silly me. I flipped it around, so unbound like that, and then what is going on? I'm overlooking something here. Actual type unbound. Array. What? That's strange. Don't know what that's about yet, but let's first do this, then it's getting a little messy. Oh, that's what's going on. Where go is this, and where what? Yeah, if I start seeing stuff like that, it's time to take a break. So I'm almost gonna stop now. So if we fail at that, then if we get nothing, we abort. Well, I think here you could also use maybe, but let's just go with it for now. Run. And then oh. This can be removed now, and that can be removed. This becomes, well, you can just say print results. Maybe I should make a run algorithms function. That's this part. Like that. Can I use maybe here? Don't think I can. No, because the maybe is as an argument, not as a return type. Nope. Yeah, that doesn't work, but this works, so yeah, this is fine. You could even do this. It's maybe a little bit overkill, but it's okay to have a little fun. And what I said earlier was that we can do this. Still works. Yeah, it's really easy to refactor in Haskell. Makes it so nice. Pum, 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 pum. Yeah. Do we have any other to-dos? Yeah, this doesn't have to be merged. Okay, I think this is a good place to stop. It's also yeah, noon for me, so I will think a little bit more about how to do one fold over the entire thing so that all facts are collected in one traversal, making it really efficient. Or well, at least as efficient as possible, because now it's going over it twice. And yeah, I think we came quite far in these 2 hours, so yeah, I'm happy with it. So thank you all for coming, and I'll see you next time. Bye.